Kia ora, good evening. Welcome to one more session of Code Night New Zealand. And tonight we have a special guest, Will Velida. How are you?
I'm good, mate. How are you?
Doing well? Yeah, it's a pleasure having you with us. So it's been a year since you last share some content with us.
I think so,
What's up?
yeah. I think my content also, just looking back to the times you've allowed me on here, content has varied slightly. So yeah, it's great to be back, and thanks once again for having me. Yeah, hopefully it all goes well. Fingers crossed.
I know, all good. You always bring pretty good content. People love it and they put feedback. And yeah, you're always welcome to
Oh, thanks,
return
man.
and share some content with us. But tonight, you're sharing something interesting, about AI, exploring semantic kernel agent framework. Wow.
Yeah.
Why that? Why AI?
Okay, I'll mention this a little bit later, but I am a bit of a skeptic and enthusiast. There's like two conflicting sides. Make myself sound more interesting than I actually am. So in my approach to AI, there's a lot of powerful use cases, and I was in Chicago for Ignite. I was lucky to be there, and when the big keynote was happening, and it was, this is a agentic world or agentic world, whatever the word is. Hopefully, I haven't butchered that. It did, I was like, oh, okay, that sounds cool. Just wait for the kind of marketing buzz to kind of go by, and then once there are decent samples out, there's decent documentation out, decent blog posts out, then we can start playing around with it. So this is where I'm at in kind of my AI agent journey, inverted commas. So yeah, hopefully I'll bring something interesting, but it's going to be real introductory, like level 100 to 200 stuff, because that's where I am in my journey. So
Yeah, no, that's great. I think we all are on the same sort of journey because that's AI agents. I think that's becoming more and more popular. There's this whole hype from the past couple of years with LLMs, and now things are just transitioning to more intelligent agents, right? So, all good. Yeah, I'm excited for this session. But before you jump, Will, let me just introduce the user group, right? To the others that are coming here for the first time. So, well, we're Code Night user group. We're a community of group of developers. We love coding. We follow best practices in software development languages and technologies. In general, we tend to explore a little bit more on Microsoft stack, but we're open to any technologies, really. And we have a particular goal, really, that to enable developers with practical knowledge to excel and launch their careers. So you're always welcome to come and learn with us. Even to share some content, feel free to ping me on the meetup. And yeah, I'm happy to discuss sessions for this year if you are interested in coming to share with us. I'd like to say we're part of AzureTire.com. We're a cloud native group of enthusiasts where we get to share the latest and greatest on the cloud native space. We're sponsored by donutfoundation.org, which is an entity that looks after the different open source .NET projects in JetBrains, software tooling for developers. With no further ado, Will, the floor is yours, man.
awesome, fantastic. Well, good evening, everyone. Thanks for joining tonight. My name is Will Valida. I am a lead software engineer and Microsoft MVP based out of Melbourne, Australia. I used to live and work in Auckland, New Zealand, but I've been in Melbourne now for almost coming up to 18 months, not quite 2 years, but it's been a long time. But today we're going to be talking about, exploring the Semantic Kernel agent framework. So in the past, I've worked a little bit with Semantic Kernel. Just basic kind of like chat applications, also using Semantic Kernel as kind of like a middleware for RAG applications. And with this whole kind of agentic world or agent world that we now kind of live in, there are various frameworks coming out. So you may have heard of AutoGen on Azure itself. I think it's Azure AI Agent Service as well. But tonight we're just going to be focusing on Semantic Kernel and the Semantic Kernel agent framework. So in terms of where I am in the whole kind of AI hype cycle, I'm both a skeptic and enthusiast. Some of the things I see some of the developments are really, really cool. Some of them are a lot more frightening. So I think we're kind of at the stage where things are still kind of overhyped in some areas. There is still somewhat of a bubble. And as we kind of work through what's possible and what's not possible, we're going to see more and more kind of skeptics rise and more kind of analysis into what these things can actually do. I'm also a Microsoft Azure MVP. My focus is on Kubernetes and open source. So I do a lot of work with open source frameworks like Dapper and Radius. And also in my day-to-day job at Mantle Group, I'm a lead software engineer. So I work with lots of different clients on if they're building stuff on .NET and on Azure. That's basically where I come into the picture and help those customers and our clients build scalable solutions on Azure, which is really cool. I've been doing that for as long as I've been in Melbourne as well. So awesome team to be a part of. So just covering what we're going to go over today, I'm going to start with just some basic introductions into what actually are AI agents. Then I'll talk a little bit about the semantic kernel and its core concepts and how that relates to the agent framework that's in preview, but a part of the semantic kernel, some of the goals for that framework, and also its current architecture. Then we'll dive into a couple of demos. Again, this is not going to be too heavy. They're going to be real light. I'm still kind of exploring and seeing how this works. But I'll show you how we can actually use agents to interact with each other, and also agents to kind of work with vector data stores and work with some concept of a memory. I'll do a little bit of a comparison with AutoGen and Azure AI agent service as well to wrap up. I haven't used either AutoGen or AI agent service Anger too much, so it will be very high level. But if you're at the stage where I am and you're kind of investigating AI agents, you're working with clients or you're working on side projects and you're trying to think, where's the best place to start? Hopefully this kind of high level will help you make some informed decisions. Cool, so let's start at the very beginning. So what are AI agents? So essentially AI agents are software entities designed to perform tasks autonomously or semi-autonomously by receiving some kind of input, processing that information, and then taking actions to achieve specific goals. Now, agents can send and receive messages and then generate responses using a combination of models, tools, human inputs, or other customizable components. So we can build agents to kind of respond to input. We can build a collection of agents that will take some input, generate some responses, do some work for us, and then return something back to us. We can build agents that require some human intervention as part of the conversation between agents. Essentially, they're designed to work collaboratively, enabling kind of complex workflows by interacting with each other. Now, the semantic kernel agent framework allows for the creation of both very simple agents and also quite sophisticated agents as well. And this is enabled through modularity, and this helps kind of build those agents which can do those specific tasks and also build it out as part of a complex workflow and make it easy to maintain at the same time. Now, what problems do AI agents solve? So AI agents offer several advantages for app development, particularly when it comes to creating modular AI components, like I talked about earlier, that are able to collaborate with each other to reduce manual intervention or the need for manual intervention in complex tasks. So some of the benefits that we can think of when we're starting to work with AI agents is that, first off, you've got modular components. So essentially, as developers, we can define various types of agents for specific tasks. So you might have an agent for API interaction. You might have another AI agent for natural language processing and another one for data scraping. And essentially, the purpose behind this is that it makes it easier to adapt the application or application as requirements evolve or new technologies emerge. And a good like-for-like comparison, if you've worked in the integration space a bit, I'm thinking particularly in kind of like workflows where you might have logic apps involved or function apps. As your workflow gets more and more complex, you need to adjust for different things. You might add another function. You might add another service bus. This is akin to maybe, well, it's kind of similar where you would create another AI agent to perform another part of an overall complex workflow. So it's almost like for like, but instead of a component like service bus or a function or a logic app or a database or an API call, you're essentially got an AI agent that's doing that work for you. Now, there's also collaboration as well. So multiple agents may collaborate on a particular task or tasks. So for example, one agent might handle data collection while another goes ahead and analyzes it. And then another one will use the results to make decisions. And this helps really distribute the workload and what a term, like the term of distributed intelligence. So you have a more sophisticated workflow, but rather than kind of creating this modular AI agent or monolith AI agent, sorry, where it tries to do everything, you can essentially split that up into multiple agents where it focuses just on one thing and it becomes part of a larger system. There's also human agent collaboration, which we can benefit from. So human in the loop interactions allows agents to work alongside humans to augment decision-making processes. So for example, your agents might go ahead and prepare data analysis that we as humans can intervene and review and fine-tune, thus producing our productivity. And then finally, there's process orchestration. So agents can coordinate different tasks across systems, tools, and APIs. And this helps to automate kind of those end-to-end processes like application deployments, cloud orchestration, or even creative processing like writing and design, so things like that. So when will we use all of this? So if we compare AI agents to kind of your more traditional AI apps where you use them for specific tasks. So you might have an AI application for prediction or classification of products, for example. Agents will introduce more autonomy, flexibility, and interactivity into the development process. So you kind of benefit from autonomy and decision making. So if your application requires entities that can make independent decisions and also the ability to adapt to changing conditions, where you might have robotic systems, autonomous vehicles, smart environments, etc., an agent framework is probably more preferable to this over a traditional AI application. If you have kind of multi-step processes that require multiple amount of agents to collaborate with each other, so this could be as part of complex systems that require independent components to work together. So really your kind of supply chain management scenarios, distributed computing, swarm robotics, etc. Agents provide built-in mechanisms for coordination between agents and also communication as well. And then there's interactive and goal-orientated outcomes as well that we can achieve with AI agents. So if your application involves kind of goal-driven behavior, so completing tasks or interacting with users to achieve specific objectives or tasks, agent-based frameworks are a better choice over traditional AI applications. So before we actually kind of kick off into what Semantic Kernel is and what the agent framework as part of the Semantic Kernel is as well, it's important to think about some of the design principles that kind of drive building AI agentic systems. So one of the cool things I think about AI agents is that ambiguity is more of a feature than a bug in generative AI. It's not where I'm like talking to my product owner and saying, oh, this doesn't work. It's a feature. It's not a bug. Why are you calling it a bug? Right? It's that kind of thinking is actually embedded in part of the AI agentic systems, because it's difficult sometimes for engineers to kind of figure out even where to start. In general, agents should be able to broaden and scale human capabilities. So this is in situations like brainstorming, problem solving, automation, etc. They should be able to fill in knowledge gaps as well. So imagine you're trying to get up to speed on a particular knowledge domain. As a consultant, I deal with this all the time, where I'm working with different clients in different sectors, and I may not know the particular domain in which they work in. AI agents are a good example where I could actually interact with an AI agent to get me up to speed on that particular knowledge domain. Agents should also be able to facilitate and support collaborations in the ways that we as individuals prefer to work with others and help us make us better versions of ourselves. So kind of like it's a weird analogy, but like a life coach or taskmaster, so helping us, augment our intelligence when we're doing specific tasks. Now, the design principles themselves kind of sit in three spaces. So you've got space, the first one, time, and then also core. So if we look at space to begin with, this is the environment in which the agent will operate. So essentially, agents should help connect people to other people, events, and actual knowledge to actually enable the collaboration and connection I've been talking about throughout this talk. Agents help connect events, knowledge, and people, and they help bring people kind of closer together. So the idea is that AI agents shouldn't be there to kind of replace the need for human beings or belittle us as human beings, but they're really designed to kind of just bring our workflows closer together. They should be easily accessible, but yet occasionally invisible. So agents will largely operate in the background and only really nudge us when it's relevant and appropriate. So if you think of an example that I talked about earlier with data processing or data analysis, I should be able to interact with an agent in the back. So for example, if I'm running an AI agent over my health and fitness data, I'll say, okay, based on the past month's worth of sleep, what should I do to help improve the amount of time that I'm sleeping or improve the quality of my sleeping? Agents should be able to go away in the background and essentially grab some information and then only come to me when it's relevant or appropriate. So if I'm saying, okay, just based off my data, that might not be a lot of data for the agent to work with. So they might suggest alternative sources of data that I can use to kind of augment my question or basically give me more insights into how I can improve my sleep quality. And essentially, a part of being easily discoverable, it's got to be easily discoverable and accessible for authorized users from any device or platform that we're interacting with our agents with. It should support a variety of inputs and outputs. So it's not just text, it's not just input from a keyboard, it's also the sound, voice, etc. And then the agent itself can seamlessly transition from the foreground to the background, proactive, reactive, that kind of thing, depending on our needs as the users. Let's take a look at time now. So this is really how the agent will operate over time. So when we talk about the past time, essentially that's just reflecting on history, including both state and context. So as agents, they provide more relevant results based on their analysis of richer historical data beyond only the event, people, or state. And then agents will create connections from past events and then reflect on memory to engage with current situations. With the concept of now, so agents should really be nudging more than notifying. So an agent will embody a comprehensive approach to interacting with people. When an event happens, agents will go beyond it, like a static notification or some static formality, such as a notification from your phone. Agents will actually be able to simplify or generate cues to direct our attention as users to the right moment. And then finally, we look towards the future. So agents should adapt to various devices, platforms. It should adapt to our user behavior, our needs from its accessibility point of view, and it's also really customizable. And then agents also shaped and evolves through our interactions with the agent itself. And then finally, core is really related to trust. So agents should be able to embrace uncertainty, but establish trust. So the level of agent uncertainty is expected. So a level of uncertainty, and this is a key element to agent design. The way that we get trust and transparency is through a foundational layer of the agent's design itself. And if you think back to kind of any responsible AI design principles that you may have heard of, essentially they still apply to the agent here. So humans are in control when the agent is on or off, and then the status of our agent is visible at all times. There is some really good documentation around agentic design principles. I will share that a little bit later. I know Microsoft have released a whole bunch of content over the past couple of days around building AI agents for beginners, and it covers this into way more detail than I have tonight. So I really recommend you go and check that out. Cool, let's switch over to Semantic Kernel. So for those of you who don't really know what Semantic Kernel is, essentially what it is, it's a lightweight open source deployment kit that allows us, development kit, that allows us to build AI agents and integrate the latest AI models into our C# code, Python code, or Java code database. I'm a .NET developer, so a lot of what I'm showing you tonight, all of it will be in .NET. But essentially, you can think of Semantic Kernel as kind of middleware that enables us to kind of build these kind of enterprise-grade AI applications. So the idea is you'll kind of define a kernel model, and then you can easily connect your code to the latest AI models as kind of new models are coming out. So if you think, compared to the large language models and small language models that were available 12 months ago, obviously there are new models coming out all the time, goes DeepSeek. Essentially, with Semantic Kernel, you don't have to change your code base too much. You essentially just add a new plugin to the latest models or reference a new of the latest models within your kernel object, and then you can use the latest models without having to rewrite your entire code base. So Semantic Kernel, when it comes to the AI agents concepts, there's kind of two things in mind. So you've got your Semantic Kernel agent framework and then Semantic Kernel itself. So going through some core concepts of Semantic Kernel is really, really key. So essentially, when you start to build a application that uses Semantic Kernel, you'll have your connection. So this is really an interface that you use to work with external AI services and data sources. So here, this example is just a really simple example how we can actually create a kernel object and then add a chat completion service to Azure OpenAI. So Semantic Kernel will create a connection to Azure OpenAI just by calling this as a service. So again, you're just pointing it to an endpoint, a deployment model, whatever authentication, whether that's through an API key or more preferably through managed identities. There you can actually just embed kind of Azure OpenAI chat functionality into the Semantic Kernel quite easily. And then you've got this idea of plugins. So plugins are essentially functions that an application can use. Now, the Semantic Kernel framework provides some ready-made plugins, but it also has the option to provide plugins that you can create yourself. So the concept here is called semantic functions. And what makes it semantic is that you provide it some information that helps Semantic Kernel figure out that this function needs to be called. So this example here that I've showed in this picture, essentially you'll have a template prompt that leaves room for the user to input some text. Then you register a function summarize text with the plugin semantic functions, where you can actually summarize what the sentence, summarize the sentence. So notice that the name of the function helps Semantic Kernel help understand what the function does and when it should be called. So that's how we can actually register functions into our kernel object. There's also the ability of native function calling as well. So this is the framework provides the ability to call native functions to carry out tasks. So essentially, here's an example of such a function retrieving content from a file. And that's a real basic example where you can actually have a native function that the Semantic Kernel framework can call directly to carry out a specific task. And then you've got planners as well. So essentially, planners will orchestrate execution plans and strategy based on the input that we provided. So the idea here is to express how things should be carried out, which then serves as an instruction for Semantic Kernel to follow. It will then invoke the necessary functions to carry out the task. So here we've got a plan where we say, okay, read the content from a local file and then summarize the content. We then add that to a sequential planner. We go ahead and retrieve the file. We provide some context variables, and then we execute the plan with the context variables that we've provided and along with the custom plan itself. So there we can actually say, all right, read the content from this file that we've uploaded or we've read into the Semantic Kernel, and then go ahead and summarize the content. That's a very simple one, but you can have more complex ones. So read from a database, go off ahead, do this task, wait for this response, etc. Cool. And then finally, memory. So memory in Semantic Kernel is essentially an abstraction and simplifying of context management for AI applications. The idea is that memory is this thing that the large language model should know about. And we can store this information essentially in what's called something called a vector store, which ends up either being in memory or an actual vector database or similar. So some vector databases that I've used in the past, so you've got Azure AI Search, Cosmos DB, NoSQL has released a vector store for the NoSQL API, which I've been playing around a little bit. But it's essentially you'll have like a scenario where facts are added to memory. These facts will be stored in the memory collection or the vector database, and then you can use that to essentially give the large language model some context or some context that it should know about when answering questions. So that's very simplification. There's also kernel memory as well, which is like a whole nother framework and package that Microsoft have released as well. So that's definitely worth checking out. Cool, now we're getting into kind of the agent framework side of things. So the semantic kernel framework serves as the core foundation for implementing agent functionality. So if you're using semantic kernel in Anger today, there's not a lot that you actually need to change to use the agent framework. It is still in preview, so there are some pre-release packages that you have to download as part of your, project solution. But semantic kernel is still very much the core of your AI applications. Now, multiple agents can collaborate within a single conversation while integrating human input. Agents can also engage in and manage multiple concurrent conversations simultaneously, and then different types of agents can participate in the same conversation. So very much the same as, trying to reflect those agentic design principles. You can have multiple agents as part of a complex workflow, which have the kind of unique capabilities, but they're all contributing as part of the same conversational, same workflow. Now, looking at the architecture before we jump into some classes, into some demos, there are a few things that we need to keep in mind with the architecture. So you start with an abstract class called an agent class, and that's kind of like a core abstraction for all types of agents. And then from there, we can actually use that to create more specialized agents. Within there, there's a subclass called kernel agent, which kind of establishes a direct association with our kernel object to enable specific agent implementations. Now, agents can be invoked directly, or we can orchestrate them within something called an agent chat, where multiple agents may collaborate or interact dynamically with user inputs. And this is great for agents to adapt to various conversation scenarios, or maybe you have a task-driven scenario that you're building. This is really good for that. Now, multiple agents of various types can participate in an agent chat within the agent channel class. And this only really concerns us when we're creating custom agents as part of an agent workflow, but essentially the agent channel class allows multiple agents of various different types to participate within a single chat as well. And then finally, messaging is kind of built on the core content types of semantic kernel communication. And this helps integrate agent capabilities into applications without having to rewrite the whole application. So if you've worked with semantic kernel in the past, there's not a lot of change with how the whole chat history works and how agent messaging works. It's very similar. So there's no need to rewrite whole applications just to get AI agents working. Cool, so let's jump into a demo. So I'm just going to get out of PowerPoint and make sure I'm in the right one. Cool, so just get my notes going here. Cool, so I'm going to go through two little demos. So this sample here is essentially we're going to use a file search tool of the OpenAI assistant agent to kind of complete comprehension tasks. So what I've got here is I've got 3 text files of just very short stories because there's still kind of API limits that I can send to my Azure OpenAI instance, but that's okay. I tried integrating a whole kind of meal plan that was talking to Martel earlier. I'm getting ready for a wedding later this year. We're still working on the date, but I'm also working on getting into shape for that. And I've got a whole meal plan. So I tried sending that up, but I've reached a whole token limit. So yeah, I didn't have a lot of time to search that out. Anyway, back to the task at hand. No, not interested in my life. So essentially what we're going to do is we've got this agent that's going to use these text files as document citations to response when it's generating responses to our questions. So before I run this, essentially, I've got a whole bunch of config that I've loaded up that's going to establish a connection to my Azure OpenAI, and I'm just going to bring this down for the readability so I don't have to scroll. So the first thing that I do, there's a whole bunch of packages that I need to upload. So again, working with configuration, the package of interest is really this. So Microsoft .semantic kernel .agents.openai. So again, this is all in preview, but if I go ahead and just copy and paste that, we can see, click on pre-release. Let's see what we've got, if it's going to show up. It's thinking about it. Cool. So there's a whole bunch of packages that are kind of in pre-release. So I've got one for, it defines a concrete agent based on Azure AI agents. There's also the package that I'm using is based on the OpenAI Assistant API. So there's a few packages here that we can use as part of Semantic Kernel agents, but I'm using the OpenAI one for now. And essentially, I'm making a connection to Azure OpenAI. So I'm creating that OpenAI client provider that's going to be used by the agent. From there, we're going to create a connection to my vector store. So I'm using an empty in-memory vector store that I'm going to use to upload the file. So from there, we're going to get our vector store client, and then we're going to go ahead and create it. And then I'm extracting the vector store ID, because once we've uploaded it, all the files here, essentially as part of defining the agent, it's very similar to how we would define a prompt when we're working with AI agents and working with AI applications in the past. But essentially for this, I'm providing it with some instructions. So I've got a document store that's going to contain the text to fictional stories. I want it to analyze the document store to provide an answer to our question. So I don't want it to look at stories outside of its document store. I always want my agent to rely on this particular store. So if you think about more sophisticated examples, if you're working with, I hate to say this, microservices AI architectures, which is a lovely buzzword, stick that on your LinkedIn, your messages will go wild. You can imagine you will have a state store, a particular store, to say to that agent, go ahead and interact with that and base your answers purely on the data within that data set. But here, again, we're just limiting it to our document store, and then we're pointing our vector store ID as part of our agent definition. So again, we're passing through the client provider, and then through our definition, we're giving it some instructions as well as a pointer to that data store, or vector store, I should say. So base your answers off that. And then from there, we're just going to interact with it and then ask questions. And then we're going to get the agent to generate a response from our input. And as we invoke that agent by specifying the assistant thread there. Cool. So let's go ahead and give this a run. Hopefully this won't take too long. I always love playing dangerously when it comes to demos, and no matter how long I've been doing this, it's uploading files now. Might just scroll
There's
in a little
always
bit.
a risk.
Always a risk, particularly when it comes to working with large language models on this machine, streaming at the same time with very suspect internet. But there we go. Okay. Didn't take too long. There we go. Enough vamping and enough, playing to the crowd. It will work. So there we go. So what's essentially happened here, before we go ahead and ask any questions, it's uploaded, it's created my vector store for me. So again, we've created an in-memory vector store, and it's uploaded these files. They're just text files for now. But if you think about vector stores that you're actually hosting somewhere, so Cosmos DB is a good example. Within your agent definition, way before your agent definition, if I go back to the code and just get rid of that, scroll up here. Essentially, when we're creating a vector store client, we can actually go ahead and reach out to external data stores like Cosmos DB and essentially upload files as part of that. Here I'm doing it with all within the same application. It's quite possible that you can have a separate agent that goes ahead and does this for you. So it actually gets as part of like uploading data, and then you might have another that establishes a connection to that vector data store and then defines this agent for it to answer questions. But from there, we've uploaded our files and then we've defined our agent. So I can go ahead, not open Postman. That's going to be interesting if it comes up. I need to remove that from my taskbar. Apologies, everyone. Close window. There we go. It's gone away from now. But now we can go ahead and actually ask it some questions. So, for example, what is the word count for each of these stories? It's going to go ahead and remember, when it's trying to generate a response or generate an answer, it's only going to use the documents that are in store. So there, it hasn't made any search, or it hasn't gone to look for other documents. Essentially, these are the free text files within my vector data store. So it's used that as sources. And as part of that, part of the output from the agents, we can actually verify which sources have been used as part of this answer. So there are some ability or some functionality which we can use for explainable AI, which is really neat. Cool. So let's ask another question. So generate a new story. I love that's a crossover of these 3 stories. I'm a big fan of Marvel's Cinematic Universe, and there's lots of crossovers, and it's getting a little bit crazy with the whole multiverse thing. So let's go ahead and do that. So essentially, there we go. So it's generated some content. So it's created a new story based on the 3 documents that are stored inside my vector store. So this is a very simple kind of agent that works by itself to essentially go and get some information or get some documents from a vector store and then answer questions based on the vector store. One thing I will try, since it's a live demo and I feel cocky, so based on these stories, generate a workout plan for me. And what I'm hoping, oh, okay, that's pretty neat. So there was 1 or 2 things that I was kind of like thinking that would happen. Either it says, I don't know anything about workout plans, but it's gone ahead and yeah, it's generated a workout plan for me based entirely on these 3 stories, which is pretty neat. Awesome, cool. Okay, nothing like vamping for just a little bit of entertainment. Oh, it's giving me a recovery drink, a water of life post-workout smoothie, crafted with spinach, coconut water, and a splash of lemon. Okay, all right. So there you go, a very enthusiastic AI agent, which is now doubled up as a workout buddy as well. Fantastic. Let's stop that before we get too silly. And I'll just get rid of Postman. Awesome. So you've kind of got this AI agent that kind of works with files or works with external information. One of the things that I think is slightly cooler, though, is the idea of multiple agents working together. And let me just zoom in on that a little bit here. So again, this is the meal plan that I tried to upload earlier, but I won't say that. Essentially here, this sample, what it will do, this uses that agent group chat concept to coordinate collaboration between 2 different agents working to review and rewrite user-provided content. And then each agent is kind of defined a distinctive role or distinct role. So here I've got 1 agent for a reviewer and 1 for a writer. And depending on a particular agent's role, we essentially provide it different instructions. So again, the reviewer is essentially given the responsibility to review and identify how to provide user content. If the user myself has provided input or direction for content already provided, it will specify how to address this input. And it never directly performs the correction or provides example as well. So if you've worked a little bit with Semantic Kernel or any kind of framework before, This is very similar to prompt engineering. So again, I'm still calling it prompt engineering. I don't want to call it prompt agent engineering. There's enough buzzwords for my liking when it comes to technology. There's always going to be more. I don't know really why I'm fighting against it. But essentially, we'll define kind of some instructions for this agent to adhere to, and also define some rules. We pass in through a kernel. We could also add some arguments, so some prompt execution settings. This is particular specific to Azure OpenAI. But then for our writer agent, we go ahead and define some different instructions. And we can essentially scope the responsibility of a specific agent through these instructions. So it's very similar to prompt engineering. Awesome. So once we've defined our agents, we can actually go ahead and define the agent group chat. And this requires considering how we're going to select the agent and determining which agent should participate or not, and when we need to exit out of the chat loop. And the way that we do that is through this kernel prompt function. So essentially what this does, so this prompt function for strategy is being defined on this agent group chat object. So essentially what it's going to do, it's going to examine the provided response and then choose the next participant. State only the name of the chosen participant without explanation, and never choose the participant named in the response. And then these two participants, so reviewer name and writer name, those are our two agents. So we're basically telling the agent group chat to say, okay, depending on the provided response, choose between either the reviewer name or the writer name. And then we define some rules as well. So if the response is user input, we're going to get the reviewer to review our input. If the response comes from reviewer name, we then hand it over to the writer's name agents and for them to go ahead and perform their task. And if the response is by the writer itself, the reviewer will then go ahead and review that. That's a lot of words, but essentially what happens is I will provide an input as a user, and the reviewer will go ahead and review that. Once the reviewer provides a response, the writer will then take that response and then depending on the response given by the reviewer, will go ahead and generate some response. And these two agents will work together until the content or the input that I provided, it makes sense and that's responded back to me. Cool, let's go ahead and actually give this a bit of a run. So just go ahead and let that start. So that's ready. So what I'm going to do is I'm just going to enter in some text around Semantic Kernel that's going to have a little bit of spelling mistakes in there. So just go ahead and enter that. So now my reviewer agent is going to take a look at that and it's going to provide me some suggestions on how to improve my content. So there we go. I'm going to let the writer do its thing, but essentially it's suggested, okay, we need to improve our grammar. So provives needs to change to provides. The relationship to their relationship, we need to enhance readability, expand our clarity, technical clarity, and also tone consistency. So if you think about the way you interact with ChatGPT and say you're working on a presentation or I would say a statement of work, but don't feed commercial and sensitive information to ChatGPT. We were working on a blog post, for example, and you provide it with a paragraph that you want to review, maybe make it more exciting, maybe check for spelling mistakes, etc. Essentially, you will provide that input to ChatGPT and it will kind of spit a response back out to you and it will wait there for you to interact with it again. The advancement here is that instead of you always talking to a particular agent, we now have multiple agents that we are interacting with. So we provided some content. We have an agent who has provided some suggestions on how we can improve that content. And then we've handed that work over to a writer agent, which has gone ahead and actually implemented those suggestions. And then we get a response from the reviewer. So the revised content has addressed all the previous suggestions. It's corrected grammar errors, improved readability, provided technical clarity, etc. And then that has been kind of copied to the clipboard. So we can actually add, if I actually go back into the code here, I've got a plugin. If I go into my Solution Explorer, and it kind of copies provided content to the clipboard. And then if I just go clipboard, and then I've added that as a plugin into my semantic kernel object. But you can think about, okay, rather than the clipboard, you can write that output out to a particular file. You can actually upload a file, get the agent to have a look at it. Then you have the writer agent implementing those suggestions and then having that content written back to the file as well. These are some things that you can use for that. Cool. So yes, that's
Will, got a question. Like, how do you know, like, when the response or the review response is, I don't know, it's is the final answer? Is there like some sort of score that you accept, or based on feedback that the agents replies, you just terminate the conversation?
It's a good question. So if I think back to the answer is I'm not entirely sure, but I'm hopefully sure that there's, well, not hopefully sure. When I think back to ML.net, whenever I made a prediction or ran some kind of algorithm, there was also like this accuracy score that where would kind of determine how well the model fit. I think in this case, it's still the need for human intervention to human verification. So I'm not sure if their SDK kind of exposes like a positive score or anything like that. Yeah, I think it still requires kind of human agent or human to kind of verify the output and make sure it's not, talking complete rubbish.
Yeah.
That's something I need to kind of look at a little bit more for a definite answer, but I would always, regardless of whether that kind of exists in underlining SDK, when it comes to generative AI applications, human verification is vital.
Yeah.
Yeah. Awesome. So I'm actually going to go back to the slides and I will display presenter view instead and go back to the slides. So anyway, just some differences between other frameworks. Again, I haven't used AutoGen or Azure AI Service or AI Agent Service in Anger too much. But for the semantic kernel, the real focus is on actually understanding and generating human-like text content by capturing deeper semantic meaning. So it's really designed to automate complex workflows and initiate tasks based on project goals. AutoGen, something that you asked me before we jumped on air today. I've read that it focuses more on event-driven and distributed agentic applications. So this is something that I'm really I'm looking forward to investigating AutoGen a little bit more. And then Azure AI Agent Service, you can use that in combination with Semantic Kernel. So you can build your application code with Semantic Kernel and then kind of host your models on AI Agent Service, kind of using the security mechanisms, data storage methods that Azure provides. Awesome. So that's pretty much it for what I have today. Thank you all for listening. I'm very excited about all of this and how accessible this is to do. I think, if I look back to kind of traditional AI applications, there was always kind of like a high barrier of entry. I mean, you could still use frameworks like ML.net. There's also Skylearn, I think. I hope I'm saying that right, for Python developers out there. I'm not much of a Python developer myself, but it's just circumstance, not denigrating our fellow Python developers, not at all. But yeah, I'm excited about where this is heading and how easy it kind of is to integrate. I think the more complex scenarios are actually integrating with proper data storage services, proper file systems. That's still a bit of a challenge. But yeah, I'd encourage folks to go ahead and play around with it, build sample applications, get your hands dirty with it. It's the best way to learn. If you want to connect with me, the good thing about having a last name like Valida is I'm pretty much Will Valida all over the internet, and hopefully that's not a bad thing. But yeah, I do a lot of stuff on YouTube. I'm building stuff on GitHub. My blog is there, wolfleader.com, where I blog about a whole variety of things, ranging from Azure Kubernetes Service to AI to networking. I'm trying to get my head around networking, trying to get deeper in that space this year. But with all of that said and done, thank you so much for listening.
Well, thank you, Will. Yeah, I guess like the source code is available on your GitHub.
Yes, I'm still working on getting that uploaded there, but that should be there either tonight or tomorrow.
All right. Yeah. Oh, exciting times. I see. I'm always interested, like when things just like even like during hype, right? It's just like for experimentation and get to know like how it works. I think like that's the year of AI agents or what's expected, right, for this year in AI. Yeah, like as you said, like there are different frameworks. They're all coming in preview, and yeah, I think like conceptually they have similar things, right? So
Mm,
you're just explaining, then I've been exploring AutoGen. Well, that's the same thing. It's just that's another implementation on top of it. There are different abstractions for sure. I think like
mm,
the semantic kernel handles really well like threads. So you
yeah.
need to specify that. While on AutoGen, you have like two options, like single threads or multi threads, but you don't need to handle or create those. It's just kind of a little bit less required. Probably there are abstractions on top of that. But yeah, they do similar things, and it's pretty interesting playing with those agents.
Yeah,
And
I'm getting my hands on AutoGen this week. I need to, so I can do that compare and contrast. Because I've
yeah,
worked with a couple of clients that have used Semantic Kernel, not the agent
yeah,
framework, but just Semantic Kernel itself, and
yeah, correct.
it's great as that middleware for AI applications. But yeah, AutoGen, it looks cool in the box, so I need to open the box and see what's inside.
Yeah, well, there are pretty good things in there. Like I like the implementation for magnetic one, which is basically self-contained agent that handles things. It has like amazing implementations like file surfer, web surfer. The, the agents basically
Mm,
handles. It can connect to your file system without you giving any authority to do things,
okay.
or a web surfer that you could simply go to the web and scrape data from web applications, which can be also uh,
Sounds
uh,
interesting.
interesting,
Just
right? So
depends on.
and dangerous at the same time. So, but yeah, man, it's powerful. Like I've been playing on that. Just make sure you spin like a VM or something else, right? Don't run your local machine.
Hypothetically, of course, we wouldn't encourage folks to.
But yeah, it's interesting. Like you can get amazed by its power, right? It will. Thanks so much, like for coming and sharing with us. This for sure, like it's just like 101, 200 level of introduction. That's pretty good, like foundation. Yeah, really liked. And yeah, so what's next for you?
What's next for me? I am speaking at Programmable in Sydney. I'll be doing a talk on cloud native platform engineering in Azure. So, got a couple of war stories. I think platform engineering is one of these fantastic evolution of terms from DevOps, which has made us a lot more money. Uh, but obviously, there's a lot more deeper levels to that. So I'll be just explaining like different stages of platform engineering and when things don't necessarily need platform engineering as well, particularly for more smaller teams.
Mhm.
Templates are fine, and then it's off to Seattle. Am I seeing you in Seattle?
Yes, I'm gonna be
Awesome,
there. Yeah,
awesome,
so
cool. We'll meet first time in a year, so or over a
nice.
year.
Yeah, correct. Yeah, it's been a long time, man.
Wow. Well,
Like yeah, just you, you're saying sorry?
Oh no, so I was looking forward to it. So
All right. Yeah, me too, man. Yeah, it's gonna be exciting. Yeah. Before we finish, right? So I just mentioned that we are going to raffle some licenses, right? So for the ones that remained on the call, right? So from the meetup uh, session, just go there and say like, please, I'd like a license. I have three. So it's just like first comers, first takers. That's it. So just go there and say hi, any sort of comments, right? We should be doing this more often. And so, well, take advantage of those licenses. And yeah, and then I'll get back to you guys later. Maybe not tonight, just late, but probably tomorrow. Then you're gonna get like your license. And thanks again, Will. And yeah, hope we catch up like on Seattle and yeah, and share like some great experience in there. So
awesome. Thanks, mate.
thank you. Yeah, we're gonna have like more sessions on Code 9 New Zealand coming in the next month. So that's already available. And feel free just to jump into the meetup and attend the next session. So yeah, well, and thanks for staying with us until the end. Thanks so much. All right. See you later.